Imagine you're on a treasure hunt. You're deep in a forest following a map. But this isn't an ordinary map. Each step leads to another clue, and you must solve them one at a time to find the treasure. Sounds like an adventure, right? Well, this is exactly how recursion works in coding. Recursion is a process where a function calls itself to solve a smaller part of a larger problem. Let's break it down with our treasure hunt analogy. You start at the first clue on your map. Each clue gives instructions to find the next clue. This continues until you find the final clue, the one that leads to the treasure. This final clue is what we call the base case in recursion. It's the stopping point, where no further steps are needed. Each clue before it represents a smaller version of the original problem, leading you step by step toward the solution. Here's what happens when we call factorial of 5. The function keeps calling itself until it reaches the base case. Factorial of 5 calls factorial of 4. Factorial of 4 calls factorial of 3. And so on until factorial 1. When we hit the base case, the recursion stops. Then we multiply the results as we retrace our steps. 1 times 2 equals 2. 2 times 3 equals 6. 6 times 4 equals 24. 24 times 5 equals 120. And just like that, the treasure, our result, is found. Recursion is powerful, but it can be tricky. Forgetting the base case is like wandering in circles without finding the treasure. And if you're not careful with how the function reduces the problem, you might end up in an infinite loop. You might wonder, why use recursion instead of a regular loop? Recursion is particularly useful for problems that are naturally hierarchical or involve breaking down tasks into similar subtasks. For example, traversing a file system. Each folder may contain files or more folders. Solving puzzles like the Tower of Hanoi. Generating fractals where each part resembles the whole. Performing complex searches like finding the shortest path in a maze. Thanks for joining this adventure into recursion. If you enjoyed this video, stay tuned for more programming concepts made simple and fun. See you next time on Animated Logic.